Hello everyone, my name is Felix Paulino, and this is my project, my statistics project, which includes the two neighborhoods I chose for this project to do rental apartments would be Midtown and East Harlem. I chose these because East Harlem is the neighborhood that I live in, and it makes the most sense for me to do these since Midtown would be classified as the school's neighborhood and East Harlem would be classified as my neighborhood. So I just wanted to compare the rents and see which one's more expensive and which one is bigger. Right? This first one right here is the Google Sheets. I don't know, you could still see it here. Mainly you don't need to see the bedroom. It's just this, I think. Rent and square footage, right? This is size, square footage, and then rent is cost or the price of each neighborhood. Here you could see one outlier, right? Because there had to be at least one in both. Because that's how like neighborhoods are. They have like a rarity between them. Rent, square footage, right? Midtown, you can see the numbers. They're higher numbers. You have 8,000, 6,000, 7,000, 8,000. Then you have this. You have East Harlem, which has 4,700, 2,000, 3,000, 4,000. Like these all show basically East Harlem. They're the neighborhood of East Harlem and the price, right? Now that I've seen this is part one of my project basically. I have it on Google Sheets, and then all the other parts are the Google Slide templates pretty much that I put all of the information of these numbers. But this for the most part is just the um the data that I collected from the 30 apartments. As you can see, it starts at 2, so it goes to 31. Right now, I'm going to exit this out, go to Google Slides, and then the next part, right? The first part was just collecting the data, so I already explained that. That's the data I collected, Midtown and East Harlem. Um, then I have here part two of my statistic project. Introductions. This is a brief explanation for this. This is the two neighborhoods I'm choosing are East Harlem and Midtown. I want to learn the difference in rental apartments between my personal neighborhood and the neighborhood where Gutman is, which is the school I go to. And I want to see the price difference of these two. The methods I used were using streeteasy.com. This is pretty much the only method I used to get to and I to get to well my answers, right, for this project were from Street Easy. And then the minimum I put was 500 using that one so that it can never go below 500. The given sample size for each neighborhood is 30 apartments. And the way I collected my data was, yes, it was randomized, right? I just went to streeteasy.com and then I randomly chose those apartments. Like I just randomly seen a price and put them apartments, the ones that had a square footage. And I did it off random so that it didn't have any biasness towards it for this like experiment. And then the research questions. The research questions, I didn't think too much about it. I just used the default ones for the project, which was which neighborhood has more expensive apartments, and then which neighborhoods has apartments that are better for. This was incorrect actually. Which neighborhood is bigger? I meant to say. Which neighborhood is bigger? This was a typo. And bigger would just be basically which neighborhood has a bigger square footage. That's like the bigger apartment. So maybe you're like, okay, you want a big apartment, but it isn't as expensive. So therefore, this is better for like families, or you would assume. Next, I have right here, neighborhood one. This is the box plot, right? I don't know. You could see it. I could zoom into it right now. You could see the numbers right there. Right. This is the box plot. And so I'm going to zoom into each one so that it could be seen pretty well. And it's 30. The mean 6,500 or around that area. Basically, the mean here already gives it away. The minimum, the maximum, the Q1s, the Q3s, you could already tell that this one is obviously bigger than East Harlem's, right? Based off these numbers. And then this is like basically the box plot information, right? The range, I calculated the IQR. It's also calculated. Neighborhood, the same thing. I prefer to use histograms, right? I would prefer to show this project with only the histograms because these have bars and these show mainly where most of the data is, like the majority of the data is, as well as the confidence intervals that do it like word wise or number wise. Instead of, you could look at these bars, are easy way to see how neighborhood one, right, has the same information right there. Put it there for a second, but it also has this bar. It goes from 2,000 all the way to 16,000. And that would obviously be considered an outlier, which is what you could only, this is why you do the box plot, just to see the outlier, the X over there. This is just extra information, to be honest. Shape of distribution can be described as, this could be described as basically a right skewed graph because it's more looks like a right skewed graph. Neighborhood 2 box plot. Now you can see this box plot is bigger within these numbers though, as the mean is 3,400 basically. So I'm just rounding each one. The maximum is 6,200. Now if you see the mean over here, you could clearly see that the mean for the first neighborhood is just clearly shown to be bigger than the second neighborhood. And I will go with many other ways to prove this without, not just these ways, by the ways of the histogram and the box plot. I'm also going to do later on hypotheses testing and confidence intervals. These are the speaker notes. I mean, this is just explanations. I'm already explaining the pictures mostly because I don't want it to take too long, this explanation. This is the box plot for neighborhood 1. No, this is like for the research questions, pretty much. But these graphs would pretty much be the exact same graphs. Actually, no. These are square footage graphs, actually. I'm mistaken there. These are to show which one is bigger, right? So I would say that not looking at the mean only determines which one is bigger, but you could see where most of the values lie within. And since it seems like the first neighborhood has more in the 1,000s, but if I go to the 1,000s here, it's smaller. I go to 1,200, it's virtually the same. So now I'm thinking by conclusion, Midtown also has the bigger neighborhood, which also kind of makes sense because if they're more expensive, they would have to give you more, which kind of makes sense to me. That Midtown would obviously be a bigger area to live in, and it costs more. It would be more expensive because Midtown is much more expensive than East Harlem, right? This is which neighborhood, yeah, which neighborhood is bigger. Although it is very close between East Harlem and Midtown, but I think the slight edge goes to Midtown based off these graphs. Right, that was part 2 of my project. This is part 3. I'm going to quickly go through these. Right, I have my analysis right here. This was from Google Sheets. Right, you could clearly see a positive correlation. You could see the linear regression and you could see the R squared. Right, now you want to find the coefficient. You just square root that number and you get this number, which is 0.76, which means strong correlation. Right, this is just the equation. I just wrote down the equation from the Google Sheets. Neighborhood 2, the same thing, but this is instead for East Harlem, which would be 0.69, meaning that actually these actually pretty much already show that 0.67 is greater than 0.69. So that means that it's also a bigger apartment. This has more bigger apartments because of the relationship between rent and square footage. Then you have neighborhood 2, East Harlem, linear regression, right? Correlation already gives it away. The histograms already give it away. These are just multiple, each part is just multiple ways of proving the same thing of the research questions, which is what I'm trying to answer. And also my entire goals for doing this, pretty much. I just did this just to see the difference between rents in my neighborhood and the schools. Finally, this is the last part of the project that I'm going to explain. Confidence levels of sample means, right? Because I wouldn't want to do extra work by trying to find proportions. Instead, I already can just have the means, the sample means for the project, right? So the sample mean here was 6,500. Sample mean here was 3,999, right? You see that the 95% tile would be 3,014 to 3. This is the interval. And this interval gives you that 95% of the values within this distribution are between these values, meaning that this Midtown most definitely for sure answers the first question, that it's easily more expensive, as well as the histograms and box plots that I just explained. And then the hypothesis testing also proves this, because now I have the null hypotheses, right? Which the null was that neighborhood 1 is equal to neighborhood 2. Yes. Midtown is equal to East Harlem, basically. Now, Midtown is greater than East Harlem would be the alternative hypotheses that I came up with. And putting this information in GeoGebra, right? You go to t-test difference of means, and you get this answer. I found that the p-value at 0.05, the p-value it gave me was 0, meaning that p is less than alpha, 0.05, so you reject the null hypotheses, right? When it's greater, you do not reject, but you do not accept. The first mean is clearly greater, and so this means that the alternative hypothesis is correct. Well, it's most likely correct because I had data to support this, and at 0.05 is greater than 0, which is alpha, meaning that this project concludes with the fact that Midtown has bigger apartments and it is more expensive than East Harlem, based off the histograms, box plots, null hypotheses, and confidence interval that I just went through briefly to present my project. Thank you.